where he is trying to attack should be in a promiscuous mode. Means the target should be ready to accept all. Then only the particular attacker can attack. That is a basic concept that you have to keep in your mind. Sniffer turns NIC. NIC, what is that? Network interface control. Of a system to promiscuous mode so that it listens to all the data. It will not restrict. I don't want this data. I don't want that data. No, it will accept all. It listens to all the data transmitted. Okay. Yes. Now, there are actually two types of sniffing called by the name of passive sniffing as well as an active sniffing. First one is called by the name passive sniffing. The passive sniffing mostly happens in hub. HUB. And I told you nowadays we are not at all interested in hub because it have its own limitations. So many limitations are there in the case of a hub. That is why nowadays we are not at all much interested in hub. We are interested in the intelligent aspect, which is called by the name the switch. That we will come to that particular topic afterwards. So the type of sniffing that is happening on the hub is called by the name of passive sniffing, and we are not much worried about the so-called passive now. Whereas we come to the real concept of sniffing, which is called, or the actual concept of nowadays, the actual concept of sniffing called by the name active sniff. Normally happens in the case of a switch. Switch is nothing but, I already told you, is nothing but a intelligent. You can just keep in your mind. We'll come to that. What is that intelligence after some time? Come to the very simple concept of switch is nothing but an intelligent. Okay, and these are the techniques that we are going to see in the coming slides, like MAC flooding, DHCP attack, DNS poisoning, switchboard stealing, ARP. We'll see one by one what are the things that we have to do. I'm not going into a elaborate fashion or something like that, but anyway, I'll give a basic idea of what are the things that you normally can happen in those concepts. Okay. Now, these are the protocol. I think in the first we have seen a word called vulnerable. Okay, there are some vulnerability that is happening on all the network. That is why we have to have a concept of man in the middle. Because of this one, exploiting the vulnerability is one of the most important concept that we normally come across. Okay, and these are HTTP. Almost all the ports. I think you all know that what is the port with and the port number, right? HTTP have a port number called 80. For HTTPS have a port number called 443. Like that, it goes. So many ports. Mail transfer protocol, telnet, so many protocols are there, post office protocol, etc., etc. Okay, now all these protocols are vulnerable, and that is why we have the concept of sniffing. Or sniffing is happening only because of this thing called vulnerability on this particular ports. Sorry, protocols. Okay, sorry. I have given the example of wiretapping. I don't want to say much on the wiretapping, the real incident of man in the middle. Okay. Now, coming to the next one. Yes, we come to the first concept called MAC, Media Access Control. Okay. Now, when you take a MAC, the MAC is actually a 48-bit address. What is that MAC address? You all know that two addresses are there, like MAC address as well as IP address, right? Now, what is the MAC address is nothing but the address which uniquely identifies as a system. I'm talking about a machine, we call it, as in the exactly in the case of IMEI. I think we are all familiar with IMEI number. So exactly like that, we have a unique MAC address for each and every system that you are working on, each and every devices that you are working on. And that unique address is a 48-bit. I hope you are able to understand what I mean by 48 zeros and ones. 48-bit address is nothing but a MAC address. That 48-bit, so automatically 48-bit means how many bytes it is? It will be 6 byte. I think you all know that 1 byte is actually 8-bit. So that our 48-bit will be around 6 byte, not around exactly 6 byte. In that, say 48-bit, the first, 6 byte, the first 3 byte is called by the name a organizationally unique identifier. Now, what I mean by this organizationally unique identifier is, suppose I buy some 10 to 15 laptops from, say, Dell, right? I am buying some 10 to 15 laptops from Dell, means that all my organizational unique identifier of the Mac in that particular thing will be the same. I hope you are able to understand what I exactly mean by that. Is when I buy some 10 Dell laptops, since all are Dell products, what happens? The first 3 byte of that, out of the 6 byte, first 3 byte will be common to all the 10. But we say that normally, what is that? Mac is unique. All the 10 are having the same first part. Means what should be the second? What should be the unique factor? The second one, which is called by the name the network interface, is the one that differs. I hope you are able to understand. So that altogether what happens? MAC address will be unique because the second 3 byte will be unique for each and every system. The 10 machine means you have 10 different network interface controller. Okay, even though you have the first 3 bytes common, the second 3 byte will be unique. Unique will be unique. So altogether, MAC address is unique. Okay, I hope you're able to understand. Now, this is the way in which I think normally MAC addresses are given, or MAC addresses are given in this format. It will be some group of 2 hexadecimal characters, separated by hyphens, or it may be a group of 2 hexadecimal characters separated by colon, or it may be, sometimes it may be a group of 3 hexadecimal characters but separated by period or dot. So that is how the max are being represented. I'll repeat that once again. That is 2 separated by hyphen, or 2 separated by 2 hexadecimal characters separated by colon, as well as 3 separated by a group of 3 separated by periods, or we call it as dots. So that is the basic concept of a MAC address. Okay. Yes. Now we are going for a real-time entity. What is that? How this MAC is going to work? Okay, for that, what I want is, I'm just going to another particular picture, which I just want to show you, because from this picture, you may not be able to understand what exactly is going to happen. Okay, so for the time being, I'm just going to, yeah, can all of you see the slide? Sorry, see the picture? I think someone can respond, okay, so that I will be able to understand that. Yes. Yeah.
Yes.
Okay. Yeah, you can just, I think Deepak, I'll contact you, okay, so that you can respond whether you are getting or not. Okay, thank you, Deepak. Yeah. So now, what is this? I just a brief idea of what is happening here. I have 4 machines called machine A, machine B, machine C, as well as machine D. All the 4 connected through a switch. I hope you are able to understand. All the 4 connected through a switch. Now, what is MAC? Now, all the machines have a MAC ID. All the machines have a MAC ID as well as an IP ID. All the machines will have an individual MAC ID as well as an individual IP ID. So that is what the picture is. Okay. Now, I just want to send 1 minute. Yeah, I just want to send a connection from, or I would just want to send a message from, what is that? I just want to send a message from what is that? A to B, right? So when I am sending a message from A to B, not from A to B, it is from A to D. When I am sending a message from, now the time being, what you are expecting is, it is only just connected. A, B, C, and D. The machine A, B, C, and D are just only connected through a switch, not a hub. Okay, it's through a switch. Now, I just want to connect, sorry, I just want to send a message from A to D. Okay. When I am sending a message from A to D, when I am sending a message from A to D, I have the details like I have the MAC ID of A, I have the IP address. Whenever you want to send something from one machine to another through a internet, through a network, definitely you need the help of the IP address. Okay. So I have the machine, I have the MAC ID. Yes, I am sending from A means I definitely have the MAC ID of A. I have the IP address of A. Plus, I do have the IP address of D. I hope you are able to understand. I'll repeat the statement. I have the MAC ID of A. I have the IP address of A. I have the IP address of D. In the sense, I don't have a MAC ID of D. That is what's going to happen. Okay. Now, when this particular message comes to the switch, when this particular message comes to the switch, there is a table in the switch called by the name cam table. There is a table in the switch called by the name cam table. I think I'll take that particular thing and show you. Yeah, there is a table in the switch called by the name cam table. Cam table is nothing but content addressable memory. Okay, just keep in your mind. Yeah. Now, when it comes to the switch for the first time, the cam table is empty. I hope you know that the cam table is empty. Now, when the cam table is empty, the switch doesn't know to which machine. When the cam table is empty, the switch doesn't know to which machine it has to send the message. To which machine it has to send the message, so that the switch will send the message in such a manner that. Now, what is the difference between hub and a switch? I told you already. Hub is not intelligent. So that whenever you get a message on the hub, the hub will do in such a fashion that it will broadcast the message. I feel like you are able to understand what I mean by broadcasting a message. Broadcasting a message means that it will go to all the machines in which the hub is connected. It will go to all the message in which the hub is connected. Whereas when it comes to switch is not broadcasting. Switch will only allow the message to go to a particular machine. That is why we call it as switch is intelligent, hub is not. Okay. Now, since the cam table is empty, what happens is switch will behave. It is for the first time. Keep in your mind, this is for the first time. Switch will behave as if it is a hub. So that what happens? The entire contents will be sent to, the entire data will be sent to all the machines in which it is connected. In the sense, what I mean by is, it will go to machine B, it will go to machine D, it will go to machine C. I hope you are able to understand. The message will go to, my intention is to send to machine D only, but unfortunately or fortunately, we can say that the content will go to all the machines, machine B, machine C, machine D. I hope you are able to understand. Machine C and B will automatically reject. Why? Because the IP is not matching. I hope you are able to understand. The machine B and C will reject as the IP doesn't match. Okay. Now, when it reaches the switch, I told you, since the cam table is empty, when it reaches the switch, cam table will get, for the first time, when the message reaches the switch from A, the cam table will get some content. What is the content? I am going to write here. It has a content in such a manner that it will have some port number. I am just giving, for the time being, I am just giving port. Yeah, I think you are not able to see. I'll write it in black letters. Port number 3. I hope you are able to understand. That is, A is connected to port number 3. That is why you got that port 3, followed by, what is that? Mac of, Mac of, or you can call it as Mac of A. So these are some other entries are also there inside. Some other entries are also there inside. For the time being, forget about those. It has, what is that? Port number as well as Mac of A being entered in the CAM table. I hope you are able to understand, right? Now, I told you already that the message will be broadcasted so that it will reach B, it will reach C, it will reach D. And fortunately, B and C will reject. But since the IP of D is matching, who will accept? Machine D will accept, right? Machine D will accept. Even though it is a broadcast message, machine D will accept. I hope you are able to understand. Okay. Then what happens next? Yes. The machine D is going to reply. Machine D is going to reply. Machine D is going to reply. I hope you are able to understand. Now, the same fashion. So machine D, the reply will first go to CAM table. Reply will first go to CAM table. First go to switch. When it reaches the switch, it checks the CAM table. I hope you are able to understand. It checks the CAM table. Now what happens? CAM table is not empty. CAM table is not empty. What it contains? It contains the port number and the MAC address of A, so that the reply, can you please come, will be broadcast intelligent. You are able to understand? Someone please comment whether the reply will be broadcast or intelligent. Yes, the reply is going to be intelligent. Very good. Understood? Now, so there ends A to D. No, once the message reaches switch, one more thing is going to happen. Once the message reaches switch, once the replies reaches the switch from what is that, machine D, one more thing is going to happen. I will repeat that. Sorry. One more thing is going to happen. What is that one more thing? Can anyone tell? It will be 4. Sorry, yeah. 4 and Mac of D gets entered into what? I hope you are able to understand. Now, one more. The last one I just want to tell you about this. Suppose now one more thing I just wanted. Now A is going to send a message to D. Will it be intelligent? Or suppose if A is going to send again to D, will it be intelligent or broadcast? It will be intelligent. Why? Because the entry for CAM D is, entry for the machine D is available in the CAM table. But suppose if machine C is going to send to machine B, what happens? It will be again, for the first time, it will be again going to be broadcasted. I hope you are able to understand. For the first time, if machine C is going in the same fashion, what we have seen, in the same fashion, if C is going to send something to B, again the same thing that is going to happen. What is that? Machine will be broadcasting. But once that first time the communication has happened between machine C and B, then what happens? What are the differences that is going to happen here? The differences are, The differences are 2 more entries will be coming here. The entries will be say 1 followed by mac of B, mac of B, and say one more port is available 2 followed by mac of D. Sorry, mac of C. After that, I think you are able to understand what I mean by. After that, if any message happens to happen from one place to another, happens to go from one place to another, all the messages will be intelligent only, because the CAM table knows to which machine it has to send. I hope you are able to understand. So now we can say that intelligent. What is intelligent? Switch is intelligent. So the first time I'll repeat the small statement. I'll repeat. For the first time, all the switches will work exactly like a hub. Once the CAM table gets the content, what happens is the switch becomes intelligent, and it will only specifically send to the respective machine. Understood? Okay. So may I go to next? Yeah. So any queries, sir? Any queries? All of you are able to understand, right? Yeah, very good. Now, my simple question is, suppose I am a man, you two are, sorry, your network is communicating. Your network is the entire network. I think some around participants, some 282 participants are there. You are all in a network. I am acting as a man in the middle in your network. I hope you are able to understand. I am acting as a man in the middle in your network. I am sending false MAC IDs. I am sending false MAC IDs somehow to your network. In the sense, you are connected through a switch. I agree. You are connected through a switch, and I am sending false MAC IDs to this particular switch. What happens actually? The thing that is going to happen at this particular point, whenever a new MAC ID comes, what happens? The CAM table gets updated. I hope you are able to understand. Whenever a new MAC ID comes, the CAM table gets updated. So now what happens is, suppose if I am keep on sending MAC IDs, don't expect that CAM table will grow. It's a bigger task, bigger table. It has its own limitation. It's only a buffer. I hope you are able to understand. It has its own limitation. It's only a buffer, so that when I keep on sending MAC IDs, false MAC IDs, I'm not sending any. When you are in a network, means only your MAC IDs are supposed to store there in the CAM table. Your MAC IDs are supposed to store there. But what I am doing is, I am in the middle attack, and I'm just keep on sending MAC IDs to your CAM table, so that what happens? Your MAC ID will get full. So once the not MAC ID, CAM table will get full. The CAM table will be full. So that what happens? Automatically, the intelligent factor of the switch will go. The intelligent concept, CAM table is not working, means how the switch will become intelligent. CAM table I have as a man in the middle, I have purposefully blocked the entire CAM table got full. There is no more enough no more MAC IDs to be stored there. And some of you have MAC IDs are not stored there also. Instead of that, I have stored false MAC IDs. What happened? CAM table got full. So now what happens is your switch will become switch will stop working, or you can call it as switch will behave exactly like a hub. Switch will change its position from intelligent to what? Broadcast. So that what happens? Whenever someone sends in your network, whenever someone sends a message, all of you, including me, since I am the man in the middle, including me, will get a copy of that. Because when the switch changes to hub, it doesn't know whether it is intelligent or not. It doesn't know how to behave as an intelligent fact. I hope you are able to understand. So that is how a man in the middle exploits your CAM table. The CAM table will normally be exploited in such a manner that some false messages, sorry, false MAC IDs are sent to your CAM table, and the CAM table will get full. Yes. Yeah, I think you are able to understand what I mean. MAC flooding, this is what I told about the name called MAC flooding. MAC flooding involves flooding the CAM table with fake MAC addresses and IP pairs until it is full. So that the switch acts like a hub. Switch will change its position to hub, so that when the legitimate users are trying to contact what are trying to send messages, what happens? Since the message is broadcasted, it will be receiving by all. Okay, your 282 friends may reject, but I may not be rejecting because I am the man in the middle. I am the attacker. Okay. So this is, I think, those who are in Linux can use this command called macoff. Those who are in Linux, you can use this command. I think you all can see this slide. Macoff, MACOF hyphen I. I means interface. MF. Yes. 1 minute. I think some of you have asking a question. Yes, Karthik, you can ask. Karthik, I think. So any query you can ask. Unmute and ask. Please make it fast because it may take some time. No. Okay. Sorry. Yeah. You can just keep in your mind. This is your statement. MACOF hyphen MACOF hyphen I followed by which connection you have. That is a LAN connection means Ethernet, or you can have the wireless connection means LO, whatever it is, where you can send this. This is a small command to send MAC IDs. Keep on sending MAC IDs in Linux. Those who are working in Linux, Kali Linux. I told you. Now, the best concept of you doing this ethical hacking is you try to do it in Kali Linux. I told you, I think in the last class itself, we have already mentioned that Kali Linux, where you can just keep a Kali Linux as a base machine, and on the top of this, try to load in virtual machine or something like that, where you can load a Windows machine, and you can just try to communicate, because this Kali have a lot of facilities, like almost all the the tools are available. Inbuilt tools are there inside Kali Linux, so that I think better you can just try example all these examples with a Kali Linux as the base in the sense you have base machine, as in one of the drive you have to load the Kali Linux, and on that you have to load a Windows operating system and try to communicate with that with a single Wi-Fi or something like that. Anyway, this is the statement. Okay. Yes. Yes. Then. Yeah, how to defend against MAC attack? Yes, definitely you have to defend against a MAC address, and one of the way to defend against a MAC address is, I think, port scanning facilities are there. There is a concept called ports. You can just keep in your mind. We are not much worried about this one for the time being. Port scanning facilities are there, where you can scan each and every ports, so that if multiple requests are coming from the same ports, we can just identify that, yeah, some unusual trafficking is doing or going from because if I am the man in the middle, I definitely may attack me connected to one of the port, even though it is I'm through one of the port only I can just connect it. So that port you can just keep on monitoring that what are the unusual trafficking done, and you can have that scanning facility. Then one another concept is actually to make sure that one port is having the facility. One of the, you can restrict like that port security can be implemented, like one of the ports should be should allow only one MAC address. That is, one MAC address can be sent from sent through one of the port, and that way of approach is there to, because if I am the man at middle attack and I am just keep on sending from keep on sending the MAC addresses, all the MAC addresses will be going through one of the port, no? So you can just monitor that port and make sure that no more entries are there. Then, okay. So I hope you are able to understand the basic concept of the. Now, this particular concept is the basic concept of whatever be the thing that we are going to see in the rest of the slides. The basic concept. There is a concept called request. There is a concept called a response. Request is A to D. Response is D to A. And this is going in this fashion where some tables are created. One of the example is the CAM table, and we know how it is working. Okay. Now comes the next one called DHCP. Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol, DHCP. Okay. Now, what is this DHCP? This is the basic details of DHCP. I am not going much details into DHCP like this. Yeah, how DHCP works, we will see. Now, previously what we have seen is we have set a static IP. I hope you are able to understand what I mean by static and dynamic. Any queries are there, means you can just ask. Okay. You have a static IP being set to machine A. You can just remember the previous picture. Machine A, I set a static IP. Machine B, I set a static IP. Machine D, I set a static IP. Machine C, I set a static IP. Okay. Now, in this particular concept, or in this concept of DHCP, you have a set of what do you call clients. You have a set of clients, say some 10 clients. You have a server in between. You have a server in between. So I call this 10 clients as DHCP clients. I call this 10 clients as DHCP clients, and I call this server as my DHCP server. So I think you can remember that concept. 10 clients are there, and in between you have one server called DHCP. Now, what is the concept of this DHCP server is? This DHCP server holds a set of IP addresses. I hope I feel like you are able to understand what I mean by a bunch. Okay, I'll call it as a bunch of IP addresses, right? So this DHCP server holds a bunch of IP addresses, and it is connected by a set of DHCP. So DHCP server holds a bunch of IP addresses and connected by a set of IP clients. Okay. Now, one of the client, say client number A, one of the client, whenever it wants to communicate to another machine, definitely we have seen it needs an IP address. We have seen in the previous slide, it needs MAC address is there with the machine itself, but whereas it needs an IP address to communicate for its purpose as well as for some others purpose. Okay, good. Now, when I am connected to my network, when the client A connected to my network, the client A is not statically connected. No IP addresses are connected to the client. The client A will automatically ask a broadcast message. Client A will automatically ask a broadcast. Broadcast message means that message will go to all, right? So 10 clients are there. The client is sending means the one of the clients sending broadcast message will go to all the 9 clients as well as the one server. Okay, good. Now, and the client A is going to send a request, we can call it as. It is not called by the name request, but for the time being, you call it as a request in such a manner that, sir, I want a IP address. It is not statically connected. It doesn't have a static IP address. I need a IP address. I hope you are able to understand. So this is a broadcast message which will be sent to all in the sense the 9 clients as well as the one server. Automatically, that is called by the name. That request is called. I am telling you it is a request, but the actual name of that is called DHCP discover. So what is a DHCP discover? Sir, I need a IP address. Right? That is the one. Where to send? From the client. To whom? The server. It will reach all, but all the other clients will discard. Only the server will accept that. Now, server will offer. The next server has to reply. Yes, I do have a bunch of IP with me. You can take one of that. The reply is in this fashion. I have a set of IP address with me, the server. All the others will discard. That particular message is also a broadcast message, so that it will reach all the 9 plus the one which have asked for. That is all the 10 clients it will reach. That is the symbol statement. All the 10 clients it will reach. The 9 will discard. Only A will accept. Call by the name DHCP offer. So who is sending? DHCP server. To whom? To all. But only who will accept? A will accept, because client A needs that. So that, okay, thank you, server. I will take that. The next query from what? Your client called A to the server. That is also again a broadcast message, but only the server will receive. That is called by the name DHCP request. So what is DHCP? I'll just come again. What is DHCP offer? Please, can anyone provide me a IP? What is DH? Who sends? A to server. Then what is the next one? Server to A, because server doesn't know from where it has. So that is why server will send back, okay, I have a bunch with me. You can take one. DHCP offer. Once the offer reaches your, when we offer something, means they will accept definitely. The client will again say, okay, I will take that DHCP request. So that DHCP reply sends the unicast message client. What is that? The IP address will be sent to the A. So that what happens? Only A got a IP address. So in the same fashion, the others, what are the others? B, C, D. Some 9 clients are also. Some 9 clients are also there, no? They will also give in this fashion, like DHCP of discover first, DHCP offer next, DHCP request next, DHCP acknowledge ACK next. So that all those individual clients will get the bunch, will get the IP address from where? The one which is being kept by the DHCP server. I hope we are able to understand. Now, actually, in the real sense, I'll just add one more point to this particular time. This particular IP, why it is called a dynamic IP? DHCP is dynamic host protocol. Why it is called a dynamic IP is the assigned, in this case, the client is assigned a IP address. Okay. It has a expiration date. I think you all know that. What do you mean by expiration date, right? In medicines and all, we do have till a particular point only, say some 1 month, 2 month only, A can hold this IP address. I hope you are able to understand. So that what happens is, again, once this expiration date is over, the IP is not usable. IP is not usable. So that again, A will have to do the same process as what he has done in the initial stage. Again, it has to give a DHCP discover. The particular, what is that? The server will send a offer to him, then request respect. So like that, a particular period of time, a ID being assigned to one of the client will remain only for a particular period of time, so that it keeps on changing. That is why it is being called by the name a dynamic host configuration port. Whereas a static IP means always. Once you set a static IP, it will be always until and unless we change that. But in this case, this IP keep on changing, because this what is that? Your DHCP server is able to supply enough IP address. Okay, so that is the concept. All of you, I think all of you are able to understand what I mean, because I just want this one to be understood. Then only I can just go to the very next one. So I think all of you have understood the basic working nature of a DHCP server and client, right? Okay. So may I go next? Yeah. This is DHCP
So,
discovery. Yes, sir. Yes,
so
sir.
in the communication is SSL certificate there, secure socket layer.
Yeah, that we will discuss after some time. Can it be? Can we discuss it afterwards? Because for the time being, we will come to that. We'll come to that. That we will discuss. Okay. So any more queries? Yeah. So may I? Yes, sir. So that is the basic concept. Now comes. I am a man in the middle. Please, all of you, please keep that basic concept with you. I am a man in the middle. So that what the example that we have seen is how many clients were there? 10 clients were there. Only one server is there. Server has enough things to supply to the what is that? The clients. They keep on working. No problem in between. All of a sudden, I came as a man in the middle. When man in the middle means I am in the network. When I am in the network, what am I? I am a client. I hope you are able to understand. I am a client now. I keep on. I told you the life of a IP address for a particular life of a IP address for a particular client is for quite some period. Say some 1 week, 2 weeks, say 1 month. Only after 1 month he may have to request for another one, a new one. Okay, understood the basic concept. I am a client. I keep on asking for new IP addresses. I hope you are able to understand. I keep on asking for IP address, IP address, IP address. Now keep in your mind that that DHCP server is not a Akshaya Patra or something like that. We all know that. What do you mean by Akshaya Patra? Akshaya Patra will keep on giving food, right? Don't worry about it. It will not be empty. But this particular DHCP server is not Akshaya Patra. There is a time where what? The bunch gets exhausted, or you can call it as there is no more bunch there. It gets empty. I hope you are able to understand, all of you. When I am the attacker and I keep on sending DHCP requests for IPs, the server is ready to give. After some time, the server will say that, please, I don't have any more to send. I hope you are able to understand. That is called by the name DHCP starvation attack. What is that starvation attack? Starvation attack is nothing but the DHCP server doesn't have any IP address to be supplied. Right? I hope you are able to understand. Okay. Now, coming to the next one. Very simple. Sorry. Based on this concept. Sorry. Once this, the DHCP server says that, once the DHCP server says that, I don't have any more. I am in our Malayalam, we call it as Patani. We are in Patani stage. I don't have anything to supply means automatically initially, I am the man in the middle. Keep in your mind. For the time being, I am man in the middle. I will change my status. Initially, I was a client. I will change my status from DHCP client to please. Yeah, that is what I want to tell you here. DHCP client to, I will change my state. I was a DHCP client previously. I make the server starvated. I change once that server becomes in a starvation stage, doesn't have enough things to supply. I will change as a DHCP client. I will change my status to DHCP server. So what happens? I am ready to give some IP address. I will change my status as a man in the middle. I am ready to give some IP address. When I am giving an IP address, a legitimate user like you, when being asked the IP address, the man in the middle is giving the IP address. So that the entire network will be under my control. I hope you are able to understand. So first, I'll just repeat in a single minute. What is that? First, I will be acting as a client. Make the DHCP server starvated so that DHCP server doesn't have any IP address to be supplied, so that it will be idle. It will stop working. So that as a man in the middle, as a client man in the middle, I will change my status to what? DHCP server. Once I change my status to DHCP server, I am the owner of IP address. I will send IP address to those who are there, who definitely, after the expiration time, definitely some of you may have to ask me, sir, please give me IP address. No, I will give, so that the entire network will be under my control, so that I am the man in the middle. I am the DHCP server. Right? Sorry, I am the wrong DHCP. I am not the correct DHCP server. I am sorry. I am not the correct DHCP server. I can say that I am the wrong DHCP server. So that is a very, very important attack that normally happens in the case of a DHCP server. Okay. So I hope all of you are able to understand what I have explained. Then you can just DHCP starvation attack. I already told you. DHCP rogged server attack also I have already mentioned. I told you previously that is one of the best way to defend these is these things are enabling the port security. That is making sure that what is that no multiple requests should come from the same port. That is the only thing that we can do it for defending against this particular key. Then the DHCP snooping is also there, which allows switch to accept DHCP server coming. That is what I told you. Trust port coming only from a trusted port. So these are the two things that you have to keep in your mind. Against, we should block this particular attack. Okay. So I hope you are able to understand these two concepts. Now comes the third. Any queries? For DHCP attack, the hacker needs a strong system. Definitely, sir. Definitely. DHCP server, hacker definitely needs a stronger system, because the problem is, Deepak, I think, yeah, very good question, Deepak. It's because why? I have to first become a client. Yeah, because multiple, yes, definitely. First, I have to become a client, and then after that, I have to switch myself to DHCP server. Okay, definitely. I should be a sir. When you are a man in the middle, what is that? When you are a man in the middle, definitely you need everything. You are. I told you in the first class itself. We have seen that. I must be skilled. No, I must be skilled enough to do anything. So definitely. Then how to prevent this? I told you, port security is one of the technique that we normally apply in the ethical hacking facility. Port security, that is making sure that no two requests come from for a particular period, say 1 month, a particular time period, no two requests. In the sense, multiple requests should not be allowed. And there is a concept called a port scanner. You can just Google it. Port scanner means that I think some of you may heard of honeypot. I think already I told you about honeypot. Whenever you have a request from someone, the copy of the request will be sent to one of the machine which we have connected. We have, in the sense, the system, our preventive system, where we have connected, and we will examine what type of request it is, and based on that we will allow or not. So those type of things are also there. These are the two facilities normally applied. That's so nowadays, actually, no many you just understand the concept. Don't worry about the preventive measures. We have enough preventive measures, but we should know these are the attacks that normally happens. Okay, thank you. Then, so may I go to next? Yes. Now comes the next one called ARP. What is ARP? ARP. Address service. Sorry. Welcome, Deepak. Sorry, sir. Okay, sorry. Yeah. ARP. What is ARP? Address Resolution Protocol. Okay, good. Here also I am just address resolution. For that, just time me, it is enough. Address resolution protocol. Here also I am just shifting my focus to a picture which I have created for you. Just wait for a second. Yeah. Now, address resolution protocol. Can we? Okay, now? Yes. Sir, we have actually, what are the things? The basic things. We have two machines. Machine number A, machine number 2B. We have IP of A.
ചേച്ചി പൈസ
Please,
ചേച്ചി പൈസ ഇട്ട് 27,000 എത്രയുണ്ട്
please
എത്രയുണ്ട് പൈസ
mute your mics. Those who are
ഇപ്പൊ മെസ്സേജ് 27,000
kindly mute your mics, please. Yeah, okay. Hello. Can you please mute your mics? Yeah, thank you. Sorry. Oh, yeah. We were talking on this. Okay. So can I continue? Okay. Yes, we have two machines. Machine A, machine 2. Sorry, I haven't given as machine A and machine 2. I'll write it here. What is that? Machine A as well as machine B. Machine B. Okay, two machines connected through Ethernet. Machine A wants to communicate. Machine A wants to communicate to machine B. Machine A wants to communicate to machine B. Yes, 1 minute. Machine A wants to communicate to, sorry, control is it. Just color is very important, right? Yeah. Machine A wants to communicate to machine B. Exactly like what we have seen previously. Now, when a machine A wants to communicate to machine B, since it is a Ethernet communication, there is a LAN connection that is being set up from A to B, you have a packet. I cannot say that packet. You have, yeah, we can call it as we have a packet called by the name Ethernet frame. That is what I have shown at the bottom. I think you can just see my what is that the mouse pointer. This is what you call the Ethernet frame. So whenever I want to connect from machine A to machine B, I have a reverse also. You should have to have a Ethernet frame to be sent from, right? So when I am connecting a machine from, sorry, when I am just sending a message from machine A to machine B, I need an Ethernet frame which contains, I am sending from A to B, which contains, what are those? I have the source IP address. What is source here? IP, sorry, machine A. What is destination here? Machine B. I have the source IP address, which is nothing but IPA. I have the IP packet, which contains IP of A and IP of B. I hope you are able to understand. Please make, and if you have any query, you can ask. Don't worry about that. So I have a Ethernet frame, which contains IP packet, which is nothing but IP of A as well as IP of B. IP is available to all because actually it is in a network. But then what is that? I have the source IP. Since I am sending from A to B, I have the source IP of A also. What is not there? The thing which is not there is, the thing which is not there is, what? My destination MAC is not there. My source MAC is there, but my destination MAC is not available. My destination MAC is not available. I hope you are able to understand. So that I cannot send this particular packet. I cannot send this particular packet. Because my destination, I don't know the destination MAC. So that what I have done is, I have given a ARP request. I have given a ARP request from A to B. When a ARP request is sent from A to B, exactly like the previous camp table that is sent, that is being created, we do have a table called ARP table. We do have a table called ARP table where the once the request, it is not the data, it is only the request from A to B is coming, we get the details of my source address, we get the details of my source address, which is nothing but which is nothing but IP of A will be available inside. IP of A, IP of IP of A will be available inside. IP of A will be stored inside. Once the request comes to B, you know what it contains. I have sorry. Not IP, it is MAC. MAC of A will be stored inside. MAC of A will be stored inside my ARP table of B. I hope you are able to understand. ARP table of B. Now, so automatically request comes. The machine B will send a response. Machine B will send a response. Yeah, sorry. Machine B will send a response. It is not the actual packet. It is only a request and response. Machine B will send a request. Right? Machine B will send a response. Once the machine B sends a response, it has the IP and MAC of B so that my ARP table of A will get what is that? My MAC of B. B. So the ARP table will get updated each and every time. Right? Once the ARP table of A, so please, I will repeat once again. First, I have to send a Ethernet frame. I have to send a packet. But what is the problem with me? I don't have that question mark the value. What is that question mark the value? MAC of B. Because MAC of B is the MAC of the destination. I don't have. So I cannot send. So what I did? I send a request. When I send a request, it is called by the name ARP request. The ARP request will reach B so that I got a value. ARP table of B will have a value called MAC of A. Automatically, this machine B will send back a response which contains the MAC of B. So automatically what happens is, instead of this, I cannot actually write here. I will write. Instead of this, what I will get is, now I will get MAC of, I will write here. MAC of B. So that what happens, I can send the Ethernet frame. Understood? So the same concept of the previous one, instead of camp table being updated, what is updating here is the ARP table is updating, and ARP table is updating through the process called what? Your request and response. Okay, so that is what is there inside your address resolution protocol, or you can call it as ARP. Sorry, 1 minute. Okay, this is what. We have a request response concept, and we are taking the MAC IDs from the individual machines and making our R table R table loaded with the data. You can just, all of you can just please note a particular your what is that command, which will work in both in what is Windows as well as Linux. We can call it as ARP-A, so that we can see the ARP table. By you can just try whenever you are getting time, you just try it ARP-A for ARP. In Windows it will work. Linux also it will work. You can just try ARP-A to get the ARP table. What are the details of it? Okay, you can see that. So may I go next? Okay, then. Now there is a concept called ARP spoofing attack. What is this ARP spoofing attack? Suppose if I am the man in the middle, I am the man in the middle, I will update the CAM table. Sorry, I will update the ARP table with my MAC address. I will update the my ARP table with my MAC address, saying that it is the MAC address of the. I hope you are able to understand. I will repeat it once again. In the case of ARP spoofing is nothing but disguising. When you are sending me a request, sorry, when you two are communicating, I will be coming in between. So A and B are communicating.